All right, today we're going to talk about how to name and how to figure out the formulas for transition metal compounds. So this is just like the monatomic compounds that we talked about last time, but now instead of a main group metal, we're going to be looking specifically at transition metal compounds. We still have ionically attracted compounds here. The only difference is that we're specifically focusing on the transition metals. So since it's still a metal, it's still a cation and it's still positive. And the nonmetals are still anions and they're still negative. But the reason why we're focusing in on transition metals specifically is because of that d orbital. If you remember from electron configuration, transition metals fill in some of their electrons in that d orbital after filling in the s orbital and before moving on to the p orbital. So because of that, they can end up having valence electrons in two energy levels, causing multiple charges. So because they have multiple charges, then they can form different compounds depending on how many valence electrons they lose. So the definition here is that they're still monatomic compounds, but we're using transition metals instead of main group metals. So the nomenclature or the naming is very similar to what we discussed last time. The cation is still written first, and so you write the normal name of the element, but you follow that element with a set of parentheses. And in the parentheses, we're writing a Roman numeral indicating the charge. So for example, if it's a copper 1 ion, we would write copper normally, and in the parentheses, we'd write the Roman numeral of 1, indicating that it's a copper 1 ion. And the anion is still written last, and the ending is still changed to "ide," so that's not any different than before. The difference here is that we need to indicate the charge with the Roman numeral in the middle. Okay, let's look at some examples. So here we're going to be finding the formula from the name. So first up, we have iron 3 chloride. So the iron is telling us what the element is. The 3 in parentheses, that's the Roman numeral 3, tells us the charge of the iron atom, and chloride, the root of that is chlorine, so we know that we're dealing with a -1 charge on chlorine. So Fe3+ is the iron 3 portion of this name. The chloride is Cl-. So together, if we crisscross those charges, we have FeCl3 because we need 3 negative chlorine atoms for every 1 positive iron atom. Next up, we have titanium 4 oxide. So the titanium is telling us the element. The 4 is telling us that it's a 4+ charge, and the oxide is your anion. So the root of oxide is oxygen, and we know that oxygen has a 2 negative charge because it's in group 6A. So together, if we crisscross those charges, we would have Ti2O4, but we can reduce this to TiO2. So what this is saying is that we need 2 negative oxygens, and each oxygen has a 2- charge for every 1 titanium 4+ ion. Okay, I want you to try to do this last one on your own first. So manganese 2 sulfide. So look at what the element is. The Roman numeral tells you the charge, and then look at what the anion is and figure out what the root element is. So take a minute and see if you can solve this one on your own. Okay, do you think you got it? So manganese, the 2 is telling us that manganese has a 2+ charge. Sulfide, the root of that is sulfur, and sulfur is in group 6A, so it forms a 2 negative ion. So together, if we crisscross those charges, we would have MnS because we need 1 2 negative ion for every 1 magnesium 2+ ion. The charges become neutral. All right, learning check number 1. So which of the following is the correct formula for chromium 6 sulfide? So take a minute and see if you can figure this out. Okay, did you make your answer choice? The correct answer here is C, CRS3. Okay, why is this? Chromium 6 tells us that it's Cr6 plus is its ion. And sulfide, the root of that is sulfur, and sulfur has a 2 minus. So if we crisscross those charges, we would have Cr2S6, but this can reduce to Crs3 because we need 3 sulfur ions for every 1 chromium 6 ion. So the correct answer here is C. On the front of your video notes guide, there's a formula box. So this is what I want you to write in that box. So how to find the charge of the transition metal, because it's really easy when we go from the name to the formula, because in the name it tells us the charge. But if we're given the formula and we need to write the name, we need to figure out what Roman numeral to use. So here's what you're going to do. The number of the cations times X, and the X is our charge, plus the number of the anions in the formula times the charge of the anion, and that has to equal 0 because we know that our ionically attracted compounds are neutral, meaning there are the same number of positives as there are negatives. So this is the formula that we're going to use to help us find the name if we're given the formula. Okay, let's look at a few examples. So here we're going to be given the formula and we're trying to find the name. And so we're going to be using our equation to see what the charge is on the transition metal. So number 1, we have iron chloride, so FeCl2. So we're trying to figure out, well, what is the charge of that transition metal ion? So remember our formula, the number of cations times X, because that's our charge, plus the number of anions in the equation, times the charge of the anion equals 0 because they're all neutral. So there's 1 atom of iron, so you can see that because it's just written as Fe, times X because we're trying to figure out its charge, plus there are 2 atoms of chlorine shown by the 2 in the subscript position, times the charge of chlorine, which is 1 minus, and that has to equal 0. So 1x plus negative 2 equals 0. So X is going to equal 2 plus. So that's the charge of the iron in the compound. So we would write this as iron 2 chloride. Okay, here's the next one, Cu2O. So looking at our equation, the number of cations times X plus the number of anions times the charge of the anion has to equal 0. So take a second and see if you can kind of work this one out. Okay, did you try? Let's review. So there are 2 atoms of copper in the formula shown as the subscript 2 times X because we're looking for the charge of the copper, plus the 1 atom of oxygen in the formula times the charge of oxygen. So remember that oxygen and all the other nonmetals, their charges stay the same. So whatever it is on the periodic table is going to be the charge. So oxygen forms a 2 minus ion. So all this together has to equal 0. So 2x plus a negative 2 equals 0. So 2x equals 2. So x equals 1 plus. So the 1 plus is the charge of the copper in the compound. So it's copper 1 oxide. Okay, learning check number 2. Which of the following is the correct name of CuF2? So here you're given the formula and you're trying to find the name. Remember, you need to figure out what the charge is of your copper ion. So take a minute and use the formula and see if you can figure this one out. Okay, do you have an answer? Okay, the answer here is C, copper 2 fluoride. So remember that fluorine is in group 7A and forms a 1 minus charge. So if there are 2 fluorines in the compound formula, then that means that copper must have a 2 plus charge. And you can figure this out using the equation. So once again, the correct answer here is C, copper 2 fluoride. All right, guys, here's the joke. Are you sure you're a cation? I'm positive. Do you get it? Because he's a cat and paw, like his paw, but he's positive because he's a cation? Okay, guys, have a great day.